This is lesson 4-1 from the Algebra Readiness textbook. For today's lesson, you'll want your chapter 4 notes and a sharpened pencil. Pause the video and try these 6 problems. Come on back to compare your answers to mine. All right, you will find that each of these problems has something in common. Let's take a look. The first one I got 160, number 2 was 73, number 3 was 51, number 4 is 48, number 5 is 177, and number 6, I got 118. What they all have in common is that these 6 problems were all divisible by their divisor, and they come out even, meaning there is no remainder in any of these answers. That leads us into what we're talking about today. We're talking about divisibility. Today's learning target is to find factors using divisibility rules. In your notes, the first vocabulary word we're going to talk about in chapter 4 is divisibility. A number is divisible by another number if the remainder is 0 when you divide. So for example, 18 is divisible by 3 because 18 divided by 3 is 6. It goes in evenly. 19, on the other hand, is not divisible by 3 because you have a remainder of 1. See this remainder of 1? So that one is not divisible because there's a remainder. Pause the video if you need more time to write it. Now there are actually some rules that you can use to know if a number is divisible by another number. So an integer or a number, positive or negative, is divisible by 2 if, make sure that you highlight this and memorize this. This is important. I know it's already in your notes. But if the number ends in a 0, 2, 4, 6, or 8, then it's divisible by 2. An integer is divisible by 5 if it ends in a 0 or a 5. A number is divisible by 10 if it ends in 0. So, even numbers we're going to define as any number that ends in 0, 2, 4, 6, or 8, or as a number that is divisible by 2. Those are even numbers. And then as a reminder, odd numbers are numbers that end in 1, 3, 5, 7, or 9. Or you could say they are not divisible by 2. So let's practice this. Is the first number divisible by the second? 567, is it divisible by 2? So what we're going to do is look at this last number, the number 7. The rule for being divisible by 2 is that the number must end in 0, 2, 4, 6, or 8. 567 ends in 7. So my answer would be no, because it doesn't end in an even number. Letter B, 1015. Is it divisible by 5? And the answer is yes. The reason that it's yes is because the number I'm dividing ends in a 5. And remember when you look at your rules that any number that ends in 0 or 5 is divisible by 5. It will go in there evenly. Letter C, 111,120. Is it divisible by 10? Well, in our rules, numbers divisible by 10 end in 0. This number ends in 0. So yes, because it ends in 0. All right, hopefully you have the hang of it. Make sure you reference back to our chart with the divisibility rules on it, and tell me if the first number is divisible by the second, and make sure to explain. Pause the video and come on back to compare. All right, so A, yes, it ends in 0. B, no, it doesn't end in 0. C, no, because 53 does not end in an even number. D, yes, because 1,118 is even. Now, those aren't the only divisibility rules there are. An integer is divisible by 3 if the sum of the digits is divisible by 3. The number is divisible by 9 if the sum of the digits is divisible by 9. Make sure you get these written down, and then let's show some examples. In this example, is the first number divisible by the second? The number is 567. Is it divisible by 3? Well, let's see. What is 5 plus 6 plus 7? I'm adding the digits together. Well, 5 plus 6 is 11. 11 plus 7 is 18. Is 18 divisible by 3? It sure is. So the answer is yes, because 18 is divisible by 3, or the sum is divisible by 3. Look at letter B. 1,015, is it divisible by 9? Well, what is 1 plus 0 plus 1 plus 5? That equals 7. 7 is not divisible by 3, or divided by 9, excuse me. So therefore, this number is not divisible by 9. No, and then because. So this would be my reason, and this is my reason here, because you're going to have to explain. All right, now I want you to try that with these. You're going to have to add, they're all 3 or 9. See that? All divisible by either a 3 or a 9. So tell me if the first number is divisible by the second number, and then explain. And it'll always be referring to the addition of the numbers, or of the digits in the number. Pause the video, come on back. All right, here we go. Letter A is no, because 6 plus 4 is 10, and 10 is not divisible by 9. Letter B is no, because 4 plus 7 plus 2 is 13, and 13 is not divisible by 3. Letter C, 1 plus 7 plus 4 is 12, and 12 is divisible by 3, so 174 is also divisible by 3. Letter D, when I add these digits together, I get 18. 18 is divisible by 9, so 43,542 will also be divisible by 9. Pretty nice pattern that you can use, right? Okay, let's go on. A factor. Factors are numbers that divide another number without a remainder. So they fit evenly into a number. So let's do an example. What numbers go into the number 30 evenly? Well, let's try it. Factors of 30 are 1 times 30, those are factors, 2 times 15, 3 times 10, 5 times 6. Now, you might have seen this before. Let's see if I can. And your teacher probably went like this. 1 times 30, these are factor pairs, aren't they? 2 times 15, 3 times 10, and 5 times 6. These are all factors of 30. They divide into 30 without a remainder. Can you list the positive factors of these 4 numbers? Pause the video, write out your factors, and come on back to compare your answers to mine. All right, when you list your factors, it's easiest to list them in pairs. 1 times 10, 2 times 5. Letter B, 1 times 21 and 3 times 7. 24 has a lot of factors. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Letter D, 31 only has 2 factors, 1 and itself. We have a special word for those. It is prime. Prime is when you have 2 factors, only 1 and itself. All right, let's give this one a try. There are 20 students singing at the school concert. Each row of singers must have the same number of students. If there are at least 5 students in each row, what are all possible arrangements? Okay, let's try again. Let's read it one more time. There are 20 students singing at a school concert. Each row of singers must have the same number of students. If there are at least 5 students in each row, what are the possible arrangements? Well, the first thing that I could think is, I could have each row of singers has to have the same number. There are 5 students in a row. So let's start here. 1, 2, 3, 4, 5. I'm going to draw a picture. So I have 5 students. So start with, see how I wrote this here? Start with the minimum number of students in the row. There are at least 5 students in each row. So I have 1 row of 5. If I have 1 row of 5, how many such rows could I have so that I get 20 students all seated? Well, the first row has 5, the second row has 5, now I have 10 students seated. Now another group of 5 sits down in the next row, and I've got 15 students seated. Another group of students sits down, and now I have 20 students seated. So in this case, I have 5 students times 4 rows gives me 20 total students. So the next one, another arrangement I could think of, now it has to be at least 5 students in the row. Well, 6 doesn't go into 20, 7 doesn't, 8, 9, but 10 does. What if I had 10 students in a row? Okay, this is going to get a little tighter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I seated the first 10. Now I'm going to seat the next group of 10. And now I've got 2 groups of 10. So 2 rows with 10 in each. 2 times 10 is 20. So I could have 5 students in 4 rows, or I could have 10 students in 2 rows. And I would still meet the criteria of having 5 students in each row and 20 students seated. How many arrangements is that? 2 arrangements. Okay? let's try another one. What are the possible arrangements for the previous example if there are 36 students singing at the concert? So there are 36 students at the concert, and then remember, 5 students minimum in each row. So some people like to do a table. Showing the number of students. Oops, sorry. And how many rows. And other people like to do a diagram. I'm not sure which one you are, but let's try it. Let's start with the first one. This time we're going to start with the table. Knowing that there are at least 5. Well, 5 does not go into 36 evenly, but 6 does. So what if I put 6 students in each row? 6 students in each row for 6 rows equals 36. Okay, let's try another one. 7, nope. 8 doesn't go into 36. 9 does. I could have 9 students in each row. 9 times 4 rows would give me 36. 10, 11, 12. I could have 12 students in each row. And 12 times 3 is 36. How about 13, 14, 15? Nope. 16? Nope. 17? Nope. 18. How about 18? 18 students in a row with 2 students in each row. 18 times 2 is 36. And then 19, 20, 21, and then it's too high. So these look like my 4, where I have at least 5 students in a row and 36 total students. So let's draw what that would look like. And so I could have 6 in a row and then 6 rows deep. Or I could have 9 and then another group of 9 and then another row of 9 and then another row of 9, and I get 36. Or I could do 12. So now I've got 12. And then another row of 12, and then another row of 12. 12 times 3 is 36. And the same thing with 18. Either way that you like to do it, however you like to do it, you have to come up with the final answer of 4 arrangements. And you need to state what each of those arrangements are. So this is your answer. Okay, the last one. Jenna is looking for ways to seat people for her wedding. There will be at least 8 tables, and each table must have at least 4 guests. How many combinations are there for 64 people? All right, so if each table has 4 guests, so I need to arrange them for 64 people. Well, start with the minimum number of guests. I could have 4 people at a table, and I need 64 total people. Well, 64 divided by 4 is 13. Oop. What did I just do there? That's not 13. 4 goes into 24. How about we say 16? It's getting late at night here. All right, so 16. So I could have 4 people at a table, and then I would need 16 tables. So this is my number of tables, and this is guests at each table. Does 5 go into 64? How about 6? Nope. 7? Nope. How about 8? 8 guests at a table, and I would have then 8 tables, because 8 times 8 is 64. And then after that, I needed a minimum of at least 8 tables. So those are my only 2 options. How many arrangements or how many combinations? There are 2 arrangements, and then you have to specify what those arrangements would be. All right, your homework, 4-1, page 174, give it a try, and make sure you ask if you have any questions.